The following program has been pre-recorded, so please don't call in at this time. If you wish to participate in the program, tune in at 5 p.m. every Wednesday for A Pause for Thought on Baton Rouge Community Radio. Good evening, fellow humans. This is Wayne Parker with A Pause for Thought here on Baton Rouge Community Radio, 96.9 FM in Baton Rouge. Well, we're glad to have you here tonight. By we, I mean, I don't have a mouse in my pocket. Lang Baker's here with us. Lang, good evening.
Howdy, Wayne.
And this is a live call-in show. Feel free to call in with your questions, comments, corrections, or what have you. 343-9927, 343-9927 to participate in our discussion here. And our discussion this evening, Lang, is, just in case you didn't know, is going to be, I realize that most of the time you voice your knowledge just off the top of your head here, but stem cells and the benefits of the stem cell research going on in the medical research community today. And Lang, I'd like to talk, or start off anyway, with a little bit about what stem cells are and the history of stem cell research. And of course, you can chime in with anything you've learned also. Correct me if I say anything you don't agree with, and that goes for the listeners too. Just call in 343-9927. Let us know what you've been learning about stem cell research in the medical fields. Anyway, Lang, okay, looking here from Medical News Today, July 2013, they say that they are basically, well, they say stem cells are a class of undifferentiated cells that are able to differentiate into specialized types. And by undifferentiated, I mean, that's, well, actually, I think that's where the name stem comes from. They are cells that are just themselves, and they're capable of transforming into all kinds of different things, other kinds of cells, right?
Yeah, like the body has a great variety of cells that are organized into tissues, and in tissues organized into organs, and they have special functions, where stem cells' only special function is to recreate themselves and to differentiate into these special functioning cells.
Well, that's what I was going to say. These specially functioning cells begin from a stem cell, I guess, is how it works. I mean, they're like branches on a stem, is kind of what I'm thinking. But
yeah, well, I'm new to all this, just like you. We did our research since our last time here.
Okay.
And in a sense, the whole human body is the product of the stem cells that were the embryonic stem cells that are one of the kinds of stem cells that a lot of this research is looking at.
There are embryonic cells and adult stem cells. Embryonic stem cells are formed during the blastocyst phase of embryological development. Blastocyst phase is like after 3 or 4 days, I think, when it's just a hollow mass of cells. It isn't anything yet except a mass of cells. But
and that's what I got out of what I read.
Okay, yeah. Now, let's see here what I've got. Some more here in Medical News Today. Okay, adult or somatic stem cells exist throughout the body after the embryonic development and are found inside of different types of tissue, such as the brain, bone marrow, blood vessels, skeletal muscles, skin, and the liver. But they also say that some stem cells may remain quiescent or non-dividing. They're kind of dormant, I guess, for years until activated by disease or tissue injury. So it's kind of like the body's own emergency repair.
Yeah, like the spare tire in the trunk.
Yeah.
Waiting there for when it's needed.
Right. If some tissue is damaged by disease or injury, there are stem cells waiting and are stimulated by whatever trauma, the body's reaction to that trauma and stimulates the cells, and then they begin forming to heal the damage. So that explains that little mystery to me, I guess. It wasn't just my mother kissing my boo-boo that made things better.
She may have activated those stem cells.
Yeah, it might have been. Yeah, well, never mind. Anyway, embryonic stem cells. Embryonic stem cells are derived from a 4 or 5 day old human embryo, which I mentioned was the blastocyst. And these embryos that are used are usually extras from multiple eggs being fertilized in vitro or in a test tube in clinics.
The ones being used in research.
Yeah, they're being used in research, or they could be one that it could. Well, yeah, the ones being used in research are often taken from a group of eggs or a group of embryos that were created, one of which was chosen to implant into a woman's uterus to create a baby. Okay, and the rest of them, they say, well, these are extras. But, you know, I got to thinking about it and looking at this, and I'm being serious here, but there's a big issue about, many people believe that a fertilized human embryo is a human being. And if we accept that premise, then if mankind is able to fertilize a female egg in a test tube, that means mankind can create mankind. And that's a heck of an issue there if we accept that premise. And it also got me to thinking a little bit further anyway, that if there's a whole freezer full of fertilized embryos in a women's clinic and the place catches fire, when the firemen come in to conduct rescues of human beings, it seems to me that if we accept the premise that a fertilized embryo is a human being, they should haul the freezer out and hook it up to a portable generator somewhere, to save the most human lives first before they save the receptionist and any doctors and people like that that are in the clinic. But anyway, that's something that I was wondering about while I was looking at all this. Let's see. Then, of course, they use stem cells. They isolate them and put them into a controlled environment where they prohibit them from further specializing or differentiating, but they're allowed to divide and replicate. And then once they get enough of these, provided they've been able to keep them from differentiating, then they have what they call a stem cell line, and they can divide these up and send them out to different scientists and whatnot to study, and they'll all have the same standard to start with, to begin their tests. Okay, 343-9927 if you'd like to call in and educate Lang or me and the rest of the listeners on stem cell research. And now, Lang, I'm going to try my ability with 50-cent words here regarding the potency of stem cells. Okay, they're divided up into different categories based on their potency. And there's the totipotent cells, which have the ability to differentiate into all possible cells. And as you mentioned before we went on the air, well, it says here their examples are the zygote formed from an egg at fertilization, and the first few cells that result from the division of the zygote. But I think you said that the totipotent cells can also become the placenta and the umbilical cord. Wasn't that what you said?
That's what I read when I was.
And they aren't considered part of the
researching.
human body, so that's a significant ability. But then there is the pluripotent, which have the ability to differentiate into almost all cell types. The multipotent, which has the ability to differentiate into a closely related family of cells. The oligopotent, which has the ability to differentiate into a few cells, and then the unipotent, which only has the ability to produce cells of their own type, but they have the property of self-renewal that is required to be labeled as a stem cell. So those are the classifications, Lang, and that's a little bit about what stem cells are.
What I came across in my readings here, I can say the most useful resources I found were at the website of the National Institute of Health. There are articles on stem cells, and also at an organization called the International Society for Stem Cell Research, which promotes understanding and research and public education about stem cell research as well. And the main discussion there of the categories you were just mentioning are research with both the embryonic stem cells and the adult stem cells as the naturally occurring stem cells. And then there's also a category that's created in the lab, which is referred to as induced pluripotent stem cells, where they take a cell that's not a stem cell at all, but then through their lab processes transform it to a cell that exhibits properties similar to an embryonic stem cell. So if they can get to the state where they can successfully produce and then do research with these artificially created induced pluripotent stem cells, they will no longer be relying on embryonic stem cells and can avoid all that controversy, the political controversy over the use of embryonic stem cells.
Okay, so this induced
Pluripotent
stem cell, it still comes from a stem cell, though. It would be an adult stem cell, I suppose, or I mean, they're not making it out of cardboard boxes or anything like that. I mean, it's an actual human cell.
Well, the way they described it is that it's engineered in the lab by converting tissue-specific cells, which are not stem cells, such as skin cells, into cells that behave like embryonic stem cells.
Okay, well, of course, this is all in, as much of this is already, but that is still in the research phases, I guess. They're just learning how to play tricks with it without really knowing what they're going to use it for, or if they can use it reliably.
They're doing the research with it. A lot of the research in uses from the readings that I did for stem cells is research to develop therapies, but also to use stem cells in other ways for testing drugs instead of testing them on a human or an animal. If they can use the stem cells to differentiate into type cells that are similar to the kind of organ they want to treat with the drugs, and they can see how these cells react, these cell cultures react to that drug without exposing humans to human testing with it. So it's used for drug testing as well.
For developing new drugs, for drug research and stuff.
Right,
yeah.
For drug research.
Yeah, so if you can simulate a set of human cells and then treat it with this drug, you can see what the drug will do to the cells, if it'll help
right,
things.
and side effects and things like that they look for. And so there's a lot of these drugs that have been rejected because they were causing liver damage types of reactions.
Kind of like ibuprofen.
So it's like getting the drug out of the line of investigation pretty early on there when they see the damages that it's causing.
Without causing damages to
with a human population.
Any sentient human or any sentient life organism. I mean, as far as we know, cells aren't sentient beings, but we don't know. Anyway. Well, actually, research on cells is fairly recent. I'm looking here at something from the UK, United Kingdom, explorestemcells.co.uk, titled appropriately or coincidentally as The History of Stem Cell Research. But they point out that stem cells were first discovered in the mid-1800s. They found or discovered that stem cells were basically that cells were basically the building blocks of life, and that some cells had the ability to produce other cells. And they began trying to fertilize mammalian eggs outside of the human body as early as the early 1900s. So this is relatively new stuff here, although I didn't know they were trying those outside fertilization in the 1900s or early 1900s. But in 1968, the first bone marrow transplant was performed to successfully treat two siblings with severe combined immunodeficiency. And then some other events were in 1978, stem cells were discovered in human cord blood. And the human cord blood is, they define it here. I have to look it up. This cord blood comes from, is called placental blood or umbilical cord blood. So it's blood taken from the placenta or the umbilical cord, which you mentioned before is not really a part of the human body. It's more of an interface, or
you could think of it as an interface between two bodies.
Yeah, it's kind of like a transporter mechanism, like on Star Trek, between the mother's body and the baby's body or whatever. But that's what that is there. And that placenta reminds me of that singer that was named back in the 70s, I think. Placenta Domingo, I think was. Anyway, the cord blood contains... Man, it's rough when you got to laugh at your own jokes. But anyway, cord blood contains all the normal elements of blood. Red blood cells, white blood cells, platelets, and plasma. But it is also rich in hematopoietic stem cells. And that's another word I had to look up, but that's blood-forming stem cells. And anything that can form blood sounds significant to me. And it says that those cord blood is similar, or the blood from the cord is similar to those found in bone marrow. The cells are found in
The stem cells found.
Stem cells found in cord blood are similar to what are found in bone marrow. And I guess that's why the earliest treatments were with bone marrow, because they know they had a rich resource here that apparently was a good match for ailing marrow.
Yeah, I think the procedure is also sometimes referred to as a stem cell transplant, not just a bone marrow transplant, but another term
yes,
for the same
the way
procedure.
the way they describe it, it is actually a stem cell transplant, even though they've called it bone marrow transplant. But that explains a lot for me, because I used to wonder, well, how do they get the marrow from one bone to another? If they're actually transferring or inserting marrow, and they don't. It's the stem cells, the blood cells, or whatever
the stem cells that can produce
the cord cells. Yes. Okay. Well, that was in 1978. 81, the first in vitro stem cell line was developed from mice. 1988, embryonic stem cell lines were created from a hamster. And I think I'll resist my urge to do that Monty Python routine, but
And spares the hamster joke.
well, your mother was a hamster and your father smelled of elderberries. Now go away, or I shall taunt you some more. But anyhow, any Monty Python aficionados out there will probably hack me up for hacking that line up. But anyhow, 1995 was the first embryonic stem cell line derived from a primate, and in 1996, Dolly the sheep was created from a cell, just developed. It says here that on July 5th, 1996, Dolly, a ewe, was the first mammal to have been successfully cloned from an adult cell. And that was a significant thing. I'm surprised we don't still hear about that sort of thing anymore. I mean, I really don't hear a whole lot about them creating other mammals or furthering that research, now that I consider it. But one little tidbit I found, and I was not able to independently verify this, but according to this one site that I don't believe was explorestemcells.com.uk or .co.uk, but they said here in this one place that the name Dolly came from a suggestion by the stockman who helped with her birth, to honor Dolly Parton, because it was a mammary cell that was cloned to create the sheep. But anyway, that's just some things people are saying. But anyway, that's the basic history that I have, anyhow, of stem cell research and what stem cells are. So, as I mentioned to you when you first came in the studio tonight, Lang, I got the impression that they can't really do a whole lot yet with stem cells, but they've got a whole bunch of research going on and a whole bunch of ideas coming up. What have you found?
Well, there is a lot of research, and I think what you're referring to with saying there's not a lot they can do yet is that there's not a lot of treatments for human diseases that have been put out there. The stem cell transplant for that's referred to as bone marrow is probably the most common, most widespread stem cell therapy that's being practiced. But there are others. You mentioned some that you found that have been approved in Europe, but we haven't heard much about over here for various therapies using stem cells.
Okay, well, I thought you'd share some of yours from here in the U.S.
Well, I don't have any others from the U.S. I have some research that's being done in the promise that they're holding out for using stem cell therapies for diabetes, heart disease, multiple sclerosis, and macular degeneration. With diabetes, they're working on trying to develop testing cells that can create new beta cells in the pancreas, and beta cells are the insulin-producing cells. And so that's a problem for both types of diabetes. In type 1, where the immune system begins to attack the beta cells, and in type 2, where the individual develops resistance to insulin, and there's a loss of beta cells in the pancreas. So they're doing research and trying to identify ways where what the genetic causes may be, with the differences and similarities between different patients, and ways to diagnose people earlier and prevent diabetes or to effectively treat the disease. And so they're pursuing both the replacement of lost beta cells and the protection of beta cells from further damage through this research, trying to generate or regenerate beta cells.
Okay, well, yeah, and I've got a little bit on regenerative work for degenerative disc disease for spines. This is one of the European sites I went to that it's titled Spine Universe, and they interview a Dr. Kalik Chang, MD, an anesthesiologist and pain management specialist, and they talk to him about stem cells and the treatment of degenerative disc disease. And he explains that in response to the question, what is degenerative disc disease, he states that as a person grows older, the natural process of aging, which he defines as the degeneration at the cellular level, can progressively change and affect the strength and structure of one or more intervertebral discs. Discs that are normally plump with water may begin to dry out, affecting their shock-absorbing capacity. And he goes on to state that they can inject stem cells, and apparently he leads me to believe here that they're doing it. They can inject stem cells into the affected discs and help to heal some of that, or maybe rehydrate them a little bit, give them back some of their elasticity so that they can work more effectively and maybe reduce the pain or eliminate the pain. But it doesn't say it here, but I read somewhere else where it says that they've been able to relieve pain for up to 2 years with this treatment. So apparently that is a viable, successful treatment of it in Europe. One thing he mentions in his closing comments, Lang, and I think you mentioned something this too, one of the possible long-term risks of stem cell treatment is tumor growth. Because one of the benefits of these stem cells is that they can grow on their own, but one of the big risks is that once they put them in the body, they're not sure that they're going to grow as expected, and that they'll stop growing when we want them to.
Right, that's part of the research that they're trying to find out how it is that stem cells do the tasks that they perform, and what the triggers are to turn them on and off, and also how they differentiate into the other kinds of specific cells. And there's some situations where they found that transdifferentiation is what they call it, where stem cells from one part of the body differentiate into cells, active cells from another part of the body, such as brain stem cells that normally differentiate into different kinds of brain cells will differentiate into heart cells, which you wouldn't want a heart cell in your brain, but I don't know what, this is all lab testing, so it's not actually in a body where they're doing this, but they're discovering that there are situations, because they don't understand the mechanisms and it's not happening in the body controlled by all the subtle processes of the body's chemistry that they don't understand. That's what they're trying to learn in the research, but obviously if they don't understand it, they haven't implemented it in the lab either. And so one of the problems is this transdifferentiation, and then there's also what you mentioned, the issue of tumors, where there's not just the differentiation issue, but also the growth and the stopping of growth at a particular
those
time.
are serious concerns. Yeah, but you may wonder if you say we wouldn't want a heart growing in our brain, but that would make it easier in our foreign policy in these other countries to win over hearts and minds, right? Boom. Anyhow,
There's also muscle heads.
yes, there are those too. Not inferring anything, are you? Let's see.
Speaking generically.
Oh, okay. Eurostemcell.org states that the most well-established and widely used stem cell treatment is the transplantation of blood stem cells to treat diseases and conditions of the blood and immune system. And you kind of touched on that too. That seems to be the biggie right now, to where they can really do a lot of good. But they also state here that since the 1980s, at least in Europe, skin stem cells have been used to grow skin grafts for patients with severe burns on very large areas of their bodies. And that's really cool, because I know that treatment for severe burns over large parts of a person's body is extremely painful and very, very risky as far as infection and whatnot. So it's nice to know somebody's using that sort of thing. And they're also they have a new treatment that's been approved for marketing in Europe. Again, according to Eurostemcell.org, stem cell-based treatment to repair damage to the cornea or the surface of the eye after an injury like a chemical burn is also on the move in Europe. So there's things coming up. And I think you mentioned earlier they've got trials to help repair macular degeneration, which is with the eye.
They're doing research into stem cell, both to understand macular degeneration through their stem cell research. That's what a lot of the stem cell research is, not just to try to develop a therapy, but also to try to understand processes that go on in the human body. And so the issue there is they're exploring ways to replace both the rods and cones that are affected in macular degeneration, but also the supporting retinal pigment epithelial cells, the RPE cells. And so they're running into more difficulty with the rods and cones because they have to establish connections with the nerve fibers, whereas the RPE cells don't. I don't know exactly how that works in the eye, but they're investigating, trying to discover how these cells work in the eye, and then when they get a better understanding of that, then they'll look for ways to actually come up with a treatment.
Right. It just seems to me like they're amassing all this really, really great knowledge, and then one day we're going to have an explosion of cures based on all this stuff. But get back a little bit to the macular degeneration type thing. You mentioned rods and cones.
Yeah, those are the cells in the eyes that are light receptors.
Oh, okay.
Rods and cones. One's more useful in dim light and just doesn't distinguish colors, and the others for color detection.
Okay, and basically the way they work is they detect the light rays, the frequency of the photons that are the individual.
They respond to it and send a message down the optic nerve.
Right.
So
well, they
it's
respond.
The brain that actually.
Right. Now you're stealing my thunder, Lang. And I know you already know this because you've learned more about the eyes than I have. But the light cells or the light energy particles. That's what
the photons.
The photons. Yes. Strike these cones and rods, and it's converted. That the frequency and the energy of that particular light particle or photon. Those are two different things, I think, aren't they? Anyway, they are. That generate the impact and the energy of the impact generates a voltage pulse that is sent to the brain, and it's that the brain looks at and compares with everything else or something like that. It's basically that way, right? We see with our brains, basically, is what I'm saying, and not with our eyes, really.
Yeah, and sometimes we see stuff that's not there because our brain says
because our brains manufacture it. Yes. Yep.
Has that activity going on, and
yeah, I'd be amazed. Most people would be amazed. I know I was when I read this one book on the eyes, and just how much of what we see we're not really seeing. It's created by our brain. And that's why you can see things that really aren't there sometimes.
Yeah, and it works with auditory and other kinds of perceptions as well, perceiving things that...
that makes sense now that you mention it. So, I mean, yeah, what we hear would also be the same thing. It's vibrations that produce a voltage pulse that goes through the brain, and that's interpreted by the brain. So, yeah, that works. Cool.
Yeah, a book by Oliver Sacks, Musicophilia, describes a lot of different cases of different kinds of activities that go awry in the brain, and some of it is like musical hallucinations.
I need to read that book. I have it at home in my library, and I started it years ago, but just wasn't in the mood for that sort of thing. Although I will say that Oliver Sacks is The Man Who Mistook His Wife for a Hat. I've read 3 times. It's a fascinating story. It's 10 clinical studies of people that he had studied with brain disorders, and it's really quite fascinating how fragile our realities are, because our realities are really our brains as far as what we perceive of it. And if that gets off a little bit, things can go really badly. But anyway, we've got Well, this is about it. So I guess we gotta ring off here, Lang.
Yeah, I would just say if there's anyone that is considering some kind of stem cell treatment or knows someone who is, an excellent resource is what I mentioned earlier, that organization, the International Society for Stem Cell Research. They have a list of things that you should know about and
the layman should
making
know
a
about. Yeah,
judgment.
just regular something that regular people should check on.
Yeah, if you're considering some kind of stem cell research, they've got some tips for you there.
Yeah, good, because there are a lot of people out there offering a lot of different things, mostly outside of the United States, I would imagine, and that's why you got to be careful. Because if you're people are desperate, they may think that they have nothing to lose, when in fact, as that website pointed out, that there are things that could make your problems worse if you try some of these things without the proper research. Okay, we got to go. You've been listening to Wayne Parker and Lang Baker on A Pause for Thought here on Baton Rouge Community Radio. We thank you for listening, and we got to go. You have a good night.